Pharmaceuticals.
The production of synthetic dyes led to scientists beginning to experiment with modifying chemicals for medical use.
Mauve was the first dye to be produced synthetically. It triggered the production of pharmaceuticals.
Wars created demand for medicines because 50% of injured soldiers died from infection.
Due to the production of medicines, specifically aspirin, bomb making became difficult because of the world's limited phenol supply.
Phenol was used as a substitute for salicylic acid, which is the main molecule in pain-relieving medications.
Because salicylic acid was irritating to the stomach lining, it was chemically modified to make aspirin.
Another type of pharmaceuticals was antibiotics, which greatly increased life expectancy.
A scientist experimentally gave his daughter Penicillin Red to treat her strep infection. He found that it broke down into sulfanilamide in the body.
This became a well-known sulfa drug that fought against infection by blocking folic acid production.
Another well-known antibiotic is penicillin, which includes its modified version, amoxicillin, along with other variations.
Penicillin fights bacterial infections with its unique structure. Its B-lactam ring breaks apart to block cell wall-producing enzymes in bacteria.
Paul Ehrlich contributed to the study of antibiotics by creating the magic bullet theory. The theory used dyes to kill infectious tissues without harming the host.
The magic bullet theory applies to penicillin because humans do not have cell walls, therefore we are unaffected by it, but it kills bacteria.
The magic bullet theory applies to penicillin because humans do not have cell walls, therefore we are unaffected by it, but it kills bacteria.
The sulfanilamide molecule is found within pronosyl red. When in the body, pronosyl red breaks down into sulfanilamide.
The salicylic acid molecule was modified to add an acetyl group to decrease its irritating properties. Penicillin. The square in the middle is the B-lactam ring, and the O on the right is replaced to make amoxicillin. B-lactam rings are not common in nature and are difficult to make in a lab because of the 90-degree angles. Single-bonded carbon and nitrogen atoms prefer a bond angle around 109 degrees, and double-bonded carbon atoms prefer a bond angle around 120 degrees. Another reason B-lactam rings are not common in nature is because of the instability. This is why penicillin has to be stored at a very low temperature. If it is heated, the ring opens and the effectiveness of the antibiotic is compromised. In conclusion, the production of these three major wonder drugs, aspirin, sulfa drugs, and penicillin, has provided many things, including cures for many ailments, longer lifespans, and the basis for synthetically modifying other chemicals for medical use. The dye industry wasn't as successful as it was. It would have taken scientists a lot longer to try chemically modifying substances, and the average lifespan may still be at 40 years old.
This presentation was brought to you by Sarah Z, Marcus M, Taylor A, and yours truly, Bradley W.